We're interested in the derivative with respect to x of x to the power of x. Now, there's a conventional way of handling this, but we're going to use an unconventional method. Now, the question that we have to answer is, how do we treat x as a base when we can't use the power rule because x is also an exponent? But we can't treat this like an exponential because x is a base. Okay, so what we're going to do is we are going to take partial derivatives. And what that means is that we keep one x constant and then we differentiate with respect to the other x. All right, so this is, I've got the exponent red so that we can keep track of our two different x's. And here's how we write the partial derivatives. D, this is a del symbol, by dx of x to the power of red x plus the derivative of, with respect to, that should be red x of x to the power of red x. All right, so now we treat each x separately. And what do we end up with? Well, here we are differentiating with respect to the black x. Okay, so we're going to use the power rule. And what does the power rule tell us? Well, it tells us, take the x and we multiply it by the exponent, which is red x, and then the exponent decreases by a factor of 1. Okay, power rule done. Okay, now we treat it like an exponent. We're going to differentiate with respect to red x. And now, how do we do that? Well, when we're dealing with an exponent, we take the original function, okay, but then we have to multiply it by the log of the base, which in this case is x. So what do we have? We've got log x times x to the x. And that looks very messy, but we can simplify this. Now, when we did this power rule, we didn't really change the value of this. In fact, this simplifies back to x to the power of x. Okay. So that means that we can factor out this. We have a common factor, x to the power of x. Okay, so we're going to factor that out. Okay, that leaves us with 1 plus log x, which is exactly what we were looking for. Bob's your uncle.